we're going to be taking a look at function composition. Now, function composition sounds new, but it's really just applying concepts that we've done in the past. One thing you're going to want to take note of is this new symbol. And here we have our function with a little circle in between. This stands for f of g. And you might see something that says f of g of x. Another way to write this is f of g of x. Now, in the past, you've done things like, let's say f of x equals 2x, and you wanted to find f of 2. Well, all you have to do is take the 2 and plug it in place of x, and that would give you your answer. In function composition, you're doing the same basic idea, but instead of plugging in a number, you're plugging in an entire function into your first function. So let's go ahead and just do a few examples and you'll get the hang of it. Here we have two functions. We have f of x equals 2x and we have g of x equals x plus 1. Let's go ahead and start by finding our f of g of x. So remember, another way to write this is f of g of x. And all we're doing is we're taking our g function, this whole function here, and we're plugging it in for x. So since we have f first, I'm going to start by writing our f function here, which is 2. And instead of x, I'm going to leave a space for parentheses because I know that's where I'm going to be plugging in my next value. Now here I have g of x that I'm plugging in, f of g. So I take this whole function here of g and I plug that in where my x would have been. Now it's just distribution and simplifying. This is going to give us 2x plus 2. And there we have our answer. So all we did was we took this whole g function and plugged it right in to this x. Let's try finding the function g of f of x. Alright, this time our primary function is our g function. So I'm going to take this whole g function here and I'm going to write, instead of my x, I'll give myself parentheses because I know I'm going to be plugging something in for that x, and then I still have this plus 1. So this g function was x plus 1, and I have this x value here. Now I'm going to be plugging in my f function. My f function is 2x. So I'm going to take this 2x, I'm going to plug it right in to the x, every x value for g. So here I'm going to put 2x, and there's not really anything to simplify here, so our answer is just going to be 2x plus 1. Okay, here we have f of x equals x squared minus x, and our second function is g of x equals 3x. This time, let's go ahead and find f of g of negative 1. f of g of negative 1. In this case here, when we have a number instead of a variable, we're going to start out the same exact way. First, we want to find our f of g function. So what this f of g means, remember, is we're going to be plugging g in, this whole function, for every x here. So my f function is x squared. I'm going to take out my x, and remember, instead of that x, I'm going to be plugging in my g function, 3x. And then I have minus another x, so I'm going to go ahead and put 3x in there for that x. And this is my f of g, right? For every x here, I just plugged in 3x. Now if I simplify this out, I have 3x squared, that gives me 9x squared minus 3x. Okay, this is f of g, but I want to find f of g of negative 1, not f of g of x. So what I'm going to do here is, and let me go ahead and give myself a little bit of space. I'm going to throw these all the way up to the top. I'm trying to find this f of g of negative 1. So now, since I have my f of g, all I need to do is plug negative 1 in for these x's. So that's going to give me 9. Instead of x, I'm going to have negative 1 squared minus 3. Instead of x, I'm going to have a negative 1. And then I can simplify this, right? So here I have negative 1 squared is positive 1. It's going to leave me with a 9 minus 3 times negative 1 is plus 3. And we're going to get an overall answer of 9 plus 3, which is 12. So f of g of negative 1 is 12. Whenever you have a composite function without a variable with a number, it's the same exact process except at the end you're plugging that number in.